Today we're going to be talking about how to calculate the angle between a vector and the positive direction of the x-axis. And in this particular problem, we've been given the vector represented by the equation I plus the square root of 3 times j. Now this equation represents our vector, and we need to calculate the angle between this vector and the positive direction of the x-axis. So the first thing we want to do is draw a picture. And we only need here our xy coordinate plane because there's no z component or k component involved. Sometimes you have I plus j plus k, like, maybe plus 0k, you'd have, plus 3k. If you have I, j, and k, then you're dealing with three-dimensional space, a three-dimensional coordinate system. But because there's no k component involved here, because we have 0k, we only have I and j represented, and I and j more or less correspond to x and y. We can deal with this in two-dimensional space. So if we have an xy coordinate system here with our x and y axes, I plus the square root of 3j can be represented by this vector here. First, we need to recognize that we have a coefficient on our I component here of 1, right? We have 1i plus square root of 3j. Remember, I corresponds to the x component, so what we can do is go out along the x-axis a distance of 1. So let's pretend here that this is a distance of 1 along the x-axis. Then our j component more or less corresponds with y, our y variable. So we want to go up a distance of square root of 3. So let's pretend that this is a distance that represents square root of 3. Well, if we just connect our initial point at the origin and our final terminal point here, then that's going to represent the vector I plus square root 3j. So we'll start here at our initial point. We'll go to our terminal point here, and this is the vector I plus square root of 3 times j. Now, a couple things that we know about the triangle here that we've created. First of all, we have a right triangle here with this angle being 90 degrees. We also know that we're looking for the angle between the vector and the positive direction of the x-axis. That's going to be this angle here, and we'll go ahead and represent that angle with the variable theta. This is the angle here that we want to find. We know that this side of our triangle is a length of 1, and that this side of our triangle is a length of square root 3. Given two sides of our triangle, we can find the value of this angle. Because in comparison to the angle, we have the length of the opposite side, right? This is the opposite side. And we have the length of the adjacent side. This is the adjacent side. This would be the hypotenuse. Which trigonometric function can we use given information about the opposite and adjacent sides? Well, of course, that's tangent. Remember that tangent of the angle theta is equal to the length of the opposite side divided by the length of the adjacent side. So what we can say is that tangent of theta is equal to the length of the opposite side, square root of 3, divided by the length of the adjacent side, which is 1. All we need to do at this point is figure out how to solve this for theta. So the first thing we want to do is just simplify and say that tangent of theta is equal to square root of 3. No need to write square root of 3 divided by 1. That's redundant. So tangent of theta equals square root of 3. Remember that tangent is equal to sine divided by cosine. So we can replace tangent of theta with sine of theta divided by cosine of theta equal to square root of 3. Now here's where our unit circle gets involved. We need to find a value for theta such that when we take sine of theta, the value of sine of theta, and we divide it by the value of cosine of theta, our result is square root of 3. Because our vector starts at the origin and moves through the first quadrant here of our two-dimensional coordinate system, we want to look at values along the unit circle in our first quadrant. Well, which of these three coordinate points here in our first quadrant are likely to give us a result of square root of 3 when we divide the y value of the coordinate by the x value? Remember that the y value is associated with sine, the x value is associated with cosine. Well, probably not square root of 2 over 2 divided by square root of 2 over 2. That would just give us 1. There's no square root of 3 value involved there. So we're probably not going to use this coordinate point here. These two are both candidates though. So If we took, for example, theta equals pi over 6, this first angle right here, and we took the value for sine, the y-coordinate, so 1/2, and we said 1/2 divided by the value for cosine, the x value, which is square root of 3 over 2, divided by root 3 over 2. What that would give us, instead of dividing by this fraction, we'd say 1/2 multiplied by the reciprocal. We'd flip it upside down and do 2 over square root 3. When we get that result, obviously we get the 2's to cancel and we get 1 over square root 3. Well, that's not quite our square root 3 value. What if we do this other one, pi over 3? Well, in that case, we take the sine value, square root of 3 over 2, that's the y value, so square root of 3 over 2, and we divide that by the cosine value, which is the x value, 1/2, so 1/2 here. When we simplify, instead of dividing by the fraction, we'll multiply by its reciprocal, so we flip the denominator upside down. Instead of 1/2, we do 2 over 1. And we get our 2's to cancel, and we're just left with square root of 3 over 1, or root 3. Perfect. That's what we had originally here. Sine of theta over cosine of theta was square root of 3. So we know now that we found our matching value here, root 3, that theta is going to be equal to pi over 3, which is the same as 60 degrees. So we can say 60 degrees here. Now you might realize, one thing you might realize is that the value on the unit circle down here at the angle 4 pi over 3, where our coordinate is -1/2 negative root 3 over 2, that if we used that value for theta, that we would get a value of positive root 3. So you might think that 4 pi over 3 was also an acceptable value of theta. However, it really isn't an acceptable value of theta, because even though it gives us root 3 here, our vector is in the first quadrant. We have a positive x value, right? This is positive 1, which tells us to move 1 unit in the positive direction along the x-axis from the origin. And then we have positive root 3. That tells us to move up toward the positive direction of the y-axis, a distance of root 3, and we end up at this point. If 4 pi over 3 was the angle that we needed, then the expression for our vector here would be -I minus root 3j. That would tell us that our x value was negative and that our y value was negative, and we would have come over here in the negative direction and then in the negative direction, and we would have ended up with a vector like this that pointed at the angle 4 pi over 3, and so we would have used 4 pi over 3 instead of pi over 3 and 60 degrees. So because our vector points toward the first quadrant, we know that pi over 3 and 60 degrees here is the only acceptable answer for the angle between our original vector and the positive direction of the x-axis.